Myself, Dr. M. Damodaran, Professor in ECE Department, SRM Madurai College for Engineering and Technology. My topic is Amplitude Modulation. Overview of my presentation is Amplitude Modulation, Generation and Detection of AM waves, Double Sideband Suppressed Carrier AM Signal. These are my overview of presentation. Now we can see what is modulation. Modulation is the process of putting information onto a high frequency carrier signal for transmission. The another name for modulation is frequency translation. Why we need for modulation is very important for transmitting the signal. If the low frequency means we cannot transmit the signal, so we go for modulation. So this is the demodulation. So the reverse process of the modulation. So the black diagram is telling about how it is doing that modulation and demodulation. So the message signal, the information signal is analog signal. So we are using one carrier wave. The combination of both signal we are sending through the modulator circuit, we can get the modulated wave. Modulated wave is nothing but that AM signal. So the demodulation is the reverse process. First the AM wave is after transmission going through this demodulator circuits. There will be a low pass filter. It will allow the low frequency. So from that we can get the message signal. So this is the simple example for amplitude modulation. The message signal M of t is impressed on the amplitude of the carrier signal C of t. So the message signal is normally denoted by M of t. Carrier signal is denoted by C of t. So the type of amplitude modulations are double sideband suppressed carrier AM signal, conventional double sideband AM signal, single sideband AM signal, vestigial sideband AM signal. So this is the type of communication system. So we can use analog communication, we can also use digital communication, we can also use hybrid communication. So we can use combination of both analog and digital is called hybrid communication. So the analog communication is divided into two parts. One is called continuous wave modulation, another one is called pulse modulation. So in continuous wave modulation, we have AM, PM, FM. AM means amplitude modulation, PM means pulse modulation, FM means frequency modulation. So similarly for pulse modulation, we have pulse amplitude modulation, pulse width modulation, pulse position modulation. So in the other side, in digital communication, we have pulse code modulation. It's denoted by PCM. Delta modulation is denoted by DM, and differential pulse code modulation is denoted by differential pulse code modulation. So these are the types of communication system. So here we can see how the AM is generating. So the type of AM modulation is how we are converting that low frequency into high frequency signal. So one is called method of generation, that is having two parts, the non-linear modulator, linear modulator. So the non-linear modulator is used for low level communication. The linear modulator is used for high level communication. So the low level communication we are using square law modulator. Another one method is balanced modulation. So in linear modulation we are using switching modulator. Similarly, based on the power levels, we can use low level modulator, high level modulators. One is for short distance communication, another one is for long distance communication. Whenever the broadcasting system, we can use the high level modulator. For short distance communication, we can go for low level modulators. So here we are explain about the low level modulation. So the generation of AM take place on a low power level. Modulation take place prior to the output of the element of the final stage of the transmitter. The linear amplifiers are required in order to avoid any waveform distortion. The advantage of this low-level modulation is less modulating signal power is required to achieve a high percentage of modulation. So the disadvantage of this low-level modulation is for high power application, it is extremely inefficient. That is the reason they developed that high level modulator. So the power level will be very high. So this is mainly used for transmission purpose. So both carrier and modulating signals are amplified first to an adequate power level. The modulation take place in the last RF amplifier stage of transmitters. The advantage of this high level modulator is efficiency is higher than low level modulators. So this is one simple circuit diagram of the square law modulator. Whenever we go for modulation, we go to convert the low frequencies to high frequency signal. Here the M of t is called modulating signal. Modulating signal is nothing but message signal. So the message signal is mixed with a carrier signal that is called C of t. The carrier signal will be a high frequency signal. Combination of this both will be U of t. By using some special circuits, the active devices are converting this circuit for transmission. So in V of t, this input for the band pass filter. So we can select a particular range of frequency for AM waveform. So this is the technique used for square law modulators. So another one type of modulation is switching modulator. By using a semiconductor diode, we can use for this transmission. So this is for a this here the diode is act as a switch to which the carrier and the information signals are applied simultaneously. Whenever there is a input, it will get the high frequency signal. From that, we can get the low frequency will be converted to high frequency signal. Then there will be a tuning circuits. By converting this information signal to high frequency signal, we can get the stable output in the tuning circuits. From that, we can get the continuous output, stable output from the switching modulator. So these are the major application of AM generation. So the main application is radio broadcasting. Early days we used AM radio. Nowadays we are using FM radio. The drawback in AM is there will be a noise. There is a major loss in the signal. So the another one application is picture transmission in a TV system. So early days we used that TV signal, the audio signal is a FM signal, the video signal is a VSP signal. VSP is nothing but a one type of AM modulation that is having the picture transmission. So the major advantage of this AM generation is the transmitter is less complex, receiver is less complex, detection is easy. AM waves can travel a longer distance, so this is having lower bandwidth, so it will be a cost efficient because the circuit is very simple. The cost of the circuit also very easy to purchase and we can easily manufacture. Main the disadvantage is power wastage take place. So when we go for double sideband or single sideband, the power consumption will be more. So the AMs will get affected due to noise because we are transmitting the amplitude modulation. The noise will be easily affected. That is the reason nowadays we are using frequency modulation instead of amplitude modulation. So this is the reverse process of the AM demodulation. The process of recovering the original modulating signal from a modulated wave is called demodulation or detector circuits. So here there are different type of demodulation circuits. So one is called the linear detectors. The non-concurrent or envelope detection. So otherwise concurrent or synchronous detection. So this is one method. So another one method is non-linear detectors, that is called square law detectors. So now we can see the square law detector. So here also we are using one diode. So the name of the diode here they mentioned as detector diode. Here the AM is the input signal. So the input signal is going to this resistance. After that we are converting this detector diode. The low high frequency will be converted to low frequency. We are having one RC circuit, the capacitance resistance circuits. So the actual information is this one. That is a double sideband AM signal. Here we are getting only the message. The envelope only we are getting in the output side. So this is the basic thing of the square law detector. So another one method is linear diode or envelope detector. Here also the same principle. So we can also change the waveforms. So when we are getting correct RC circuit, the envelope will be like this. There is a change in the RC. So we can get too large signal, envelope signal. So there is a possibility of error. So here also the RC is too small. We can get one small envelope like this. So this is our actual information. This is the correct output. These are the some of the noise affected output signals. So these are the some of the drawback in the linear diode or envelope detectors. So here they mentioned the operation of this linear diode or envelope detector. So here the diode is operating in a linear region. So the characteristics can extract the envelope of an AM wave. Such detector is called envelope detector. So the main advantage of this envelope detector is, so this is one popular circuit. So the circuit is very simple. So this is very less expensive. So similarly, we can also generate that double sideband. So we have both upper sideband and lower sideband in the AM waveform. So the transmitted power is saved here through the suppression of the carrier wave because it doesn't have any useful information, but the channel bandwidth requires in the same as before. So this will consume more power because we are getting both sides waveform, the upper side and the lower side. So this is one simple basic diagram of that generation of double sideband suppressed carrier AM signal. So the input is a modulation signal. So that is information signal. This is going through one transistor circuit. This is act as a gate circuits. So we have FET in this. So QA, QB is act as a switching network to get the continuous output. So we can get both upper side and lower side AM signals from this. Finally, we can get the double sideband suppressed carrier output signal. So these are the reference I used for this preparation. Thank you.